or just finished this slide last time, I don't remember, but basically these are the commands, and this is not the whole set of commands. If you do FTP in a command box, in a DOS box, and then you can say help, it will list a whole set of commands. And so these are some sample examples of the commands FTP will understand. User, username, password, pass, list is directory, retrieve file name is like getting the file name, storing the file name is like putting a file name. Anyway, the responses come back with a number and the text. If it is a GUI kind of interface, then you will see this user, okay, password required. If it is not a GUI, then you will see probably the whole thing. Anyway, the key thing to remember in FTP is that there are two different TCP connections, a control connection and a data connection. As opposed to in HTTP, there was only one connection that was used for both control and data. So the main difference in FTP is that it is two separate connections. All right. Then so every time you retrieve a file, a new connection is set up and broken down, and the file is sent. File is done, and the control connection remains throughout. So the final thing we come to is not the final thing, but the next application we come to is electronic mail. So most of you have been using electronic mail, and at least know that you have a mail server. Your mails come to the server, and your computer is what we call a mail agent or user agent. And some of the mail can come to the user agent, and most of it is stored in the server. And once it is transferred, you can delete it from the server. Anyway, servers use a protocol to talk to each other, and that protocol is called SMTP. Simple Mail Transfer Protocol. So when you want to send a message to somebody else, you just give it to the server, and it doesn't really gone anywhere other than the server. Server keeps a queue of messages to send, and it is quite possible that the server of the receiver is not available right now, or something like that. Then it will keep trying. All right. So basically, each server has a queue of messages that need to be sent out to the next server. Now, it doesn't have to be directly to the destination. It is quite possible that a message can go to some intermediate server. From there, it can go to some other server before it reaches the final server. So it is a store and forward kind of thing, as opposed to FTP, where there is no store and forward. In FTP, the destination and the receiver have to be both up at the same time before FTP can take place. You cannot submit a command today and get the answer tomorrow in FTP. In mail, you can do that. You can send the mail today and get it tomorrow. So basically, SMTP is the protocol. SMTP stands for Simple Mail Transfer Protocol. This is one of the oldest protocol. Basically, when they invented internet, one of the very first applications that they started using was the mail. And it allows only 7-bit ASCII messages. In those days, back in 70s, we didn't have all these different encodings of the characters that we have today. And only thing we knew was ASCII. In ASCII, every character is encoded as 7-bit. Every character is from 0 to 128 because of that 7-bit. And so that's the only thing. Now, if you want to send a program or something which is a binary object which has 8 bits, you need to convert 8 bits to 7 bits. So there are methods of changing, coding 8 bits to 7 bits. And basically that means you need more than 1 byte to send those extra bits. And this protocol originally used port 25. So that is port 25 is the default port. So far we have 3 applications. What is the default for HTTP? Port for HTTP? 80. For FTP, somewhere from here? 21. and for SMTP it is 25. It is not necessarily the only port that you can use. You can use any port you want, but the users have to know that port then, and then they can use that port. Otherwise they will be talking to the wrong port. So here's the exchange. And again, interesting thing is that you can do this on your computer. You don't need a mail program to do this. On a computer, you can say telnet to mail.cs.wushtel.edu port 25. Telnet means basically you are connecting to that port and everything that you are typing is going to that port. Okay, so that port doesn't know that it is talking to you directly on your keyboard and not to a program like Outlook. Outlook does this for you. Then server will say, when you say this, the first thing server will say is 220 postoffice.cs.wushtel.edu Microsoft ESMTP mail service version so and so forth 75 ready on Tuesday 13 September 2011 this time. Okay, then you can say hello, and hello has to be spelled like this, HELO. acm.org. Now why HELO and not HELLO? Because every bit and byte was important in those days in 74 when it was done, and why is spelled two letters when only one will do, right? So they said hello acm.org. So this one says 250, server says 250, post office sees. Anyway, one of the things you will notice is that every time there is a number, just like we saw in HTTP, that number is the status code that the computers can understand. And then there is a text which computers don't care. They just flash it to the user. The users can understand those things. So this one says 250, post office sees blah 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 address. Then you can type mail from jane@acm.org. So this is the mail from field. Then it says sender OK. Then receipt to, this is the to field, and then it says OK. Then you say data, and then you can start typing whatever you want to type. It will say, first it will say start mail input end with crlf.crlf. You know what is CRLF? Yeah. Character and line feed. So that is character 13, LF is 10. SE character 13 and 10 followed by a dot. And so I typed, actually this is all I typed. So I typed this is test email dot. This serves as an example for CS473 class dot. And then on the last line I said dot. Right? When the last line is dot, that means this is the end of the message. That dot will not be sent, but basically this is the end of the message. And so 250 mail queued for delivery. Then I said quit and said bye. And you can do that yourself on your computer. Yeah. Yeah.
So on the fourth line where it says 250 post office, whatever, and then it says hello. What's the hello part? Is that the topic of the email?
Okay, so basically I told him who I am. So I said that I am calling from acm.org. This is my site. It could be harvard.edu or something. Okay. Then it says this server says okay, this is coming from this website. Not this site. cs.wushtel.edu post office. So that's its name. And that is the IP address. That is the IP address for this same thing. I'm sorry. Does that answer your question? Okay, what is the question next? Yeah.
Is there any sort of security built in so that I can't just say I'm like president at whitehouse.gov?
Yeah, there is no security built in even today. You can go to Outlook, and when it says username, just put that president at whitehouse.gov. It will take it. And when you send the email, it will go. And when the person receives it, it will say president at whitehouse.gov. However, if they wanted to trace it back, they can trace it back to you because of the IP address.
So if you send a dot from some random internet cafe.
I have gotten emails from god@heavens.com, right? Obviously from president at whitehouse.gov, anybody has gotten, everybody has gotten. So you can write whatever you want, they don't check that.
So when you say hello, acm.org, what's the point of that if it doesn't really even check anything?
Yeah, it doesn't check anything. It doesn't check, but basically when they designed the protocol, they just designed it so that first you tell where are you calling from and where you want, and then you say, what is your email address. And so first it said acm.org. Actually that is kind of irrelevant, because when I say mail from jan@acm.org, I'm telling the same information again. Right? So the first handshake actually doesn't do much. Now this is a really good exercise. You can just try it from your DOS box. Everybody understands what is a DOS box, right? And so you can just try it, and I typed it as again before. When you type something, it will not be echoed, and that's the problem. Whatever this response comes back will be written up. So you will get the server responses, but when you type hello, hello acm.org, that will be blank. You just type hello acm.org. Also another thing you can do is, if you have a program like Wireshark, which we actually provide to our students in network security class, Wireshark lets you trace basically see all the messages that are going out of your computer. If you had Wireshark, you can see these messages going in and out of your computer exactly as they are written here. And so even if you use Outlook, Outlook does send these messages to the server. Outlook tells the server, hello, this is acm.org, and then it says mail from, and so on and so forth. So Outlook is simply a what they call interface. It uses this protocol to talk to the server. Is it clear? Yeah.
Is this post office that sees Boostula.edu only able to send mail to Boostula.edu?
No, you can send mail to anybody. No, I just put here, I could have sent the mail to White House or whatever it is, so that doesn't matter.
Because it's saying, I'm trying to saying unable to relay for any other email.
Unable to relay. It says unable to relay?
Unable.
Yeah. Okay, so that is the built-in feature at WashU server. So WashU server does not let unauthenticated users. If you are authenticated, then yes, you can send it. If you are unauthenticated, then only you can send, actually I don't know what you can do, because unauthenticated, it will probably let you send to only Boostal people or something like that. But you have to give the username and password. Yeah, question?
I tried what was in the slide, but when I typed in receipt to
jan@boostal.edu, receipt to jan@boostal.edu, and it says invalid address. Okay, well that's a valid address, but I don't know why it is invalid. That's a valid. See again, this might be the case of Boostal. See, the thing is, there are some additional restrictions put by, actually our server, I'm going to come in one more minute. I mean, our server doesn't even use port 25. Okay? So that is additional security that we have built in, and I think the port number is 465 or some number. I have to go to my Outlook and see what instructions they have given me. But this is the starting, simplest, unencrypted mail. In fact, today's email, if you were to send it today, I mean, I don't. This one worked actually from my home, or maybe office. I don't remember whether I did this in the office or home. But at the office, there is no authentication required. But from home, if I do it, I get that relay message issue. If you are connected on the wireless, there are two wireless connections. One is secure and one is normal one. If you are on the normal guest one, obviously they have to have protection. But so otherwise, I will have to put a command here, user and password, to authenticate myself. All right. So that gives us a summary of the difference between HTTP and SMTP. HTTP can be persistent or non-persistent TCP connection. Everybody remembers what is a persistent TCP connection? right? You did probably in the homework as well. But persistent means you don't close, you can close, non-persistent means you close the connection after every object. Here in SMTP, this whole conversation that we had was one connection. This is mostly pull, means you get the information from the server. This is mostly push. SMTP protocol is used to send the mail, not to receive the mail. Okay? So this is mostly push. Accepts, I'm going to come to the receiving mail in a minute if that is your question. But accepts binary objects. HTTP was designed when we understood the binary objects. This accepts only 7-bit ASCII. This has one object per response. You can get multiple objects per message. Okay, so you could have a message which has a picture in it and web pages and everything else. Alright, so how do you get the email? So to get the email, you need another protocol, which is the access protocol, to get the email from your server. And the protocol that is used for access is called Post Office Protocol, POP. All of you have heard POP, right? But never knew that was Post Office Protocol, right? So POP is the Post Office Protocol, and nowadays we have version 3 of that, so we call it POP 3. Yeah.
Both of these seem like they're more pull protocols, but it.
This is pull, that is push.
Yeah, but it seems like when Outlook hooks up to Exchange, Exchange pushes email towards the Outlook client.
Yeah, right. So you are looking from the client's point of view.
Yeah.
From the client's point of view, this is a push and this is a pull. And when you go to Exchange, when you send a message, you are pushing. When you are receiving a message, you are pulling. Is it any different?
But so here, the user agent is the one that requests the emails. Yet, if your Outlook client is hooked up to Exchange, Exchange is the one that gives the emails to the Outlook client, right? Your
Exchange is, I think, more like a server, right?
Yeah.
Exchange is your server. Outlook is right here. So this is Outlook, this is Exchange. So from the Outlook point of view, you are really using POP. So I'm sorry, I didn't understand the question.
So here, the user agent is the one that's requesting email.
Yeah, in this case, on this side, on the right side, the user is requesting the email.
But it seems like in modern Outlook and Exchange, it seems like Exchange is pushing email towards Outlook.
Is pushing email towards Outlook.
Explicitly requesting.
Okay, all right. So I mean, like that's a detail. Basically, is that what you are saying is that when does this happen? Whether this is started by this side or that side. Okay, so it's quite possible that the Exchange does it the other way around, pushes it. Okay. The key is that there is a different protocol. So basically, the summary is that for sending SMTP, for receiving you need a POP protocol. And therefore, sometimes you have two servers, and you have to write down smtp.yahoo.com, pop.yahoo.com, right, for sending and receiving. Sometimes there is only one. So in our case, we write down mail.ch.bustal.edu because the same server does both, right? But it uses two different protocols, right? So even though it is mail.ch.bustal.edu, same computer, but when I send the email, I talk to it by SMTP. When I receive the email, I talk POP. Yeah.
So how is push even possible since users don't generally have stable IP addresses? Isn't always full?
No. Stable IP has nothing to do with any of this. So first of all, when you are talking to the server, you have an IP address. Doesn't matter what was your IP address yesterday, who cares? But right now when you are talking to me, you have an IP address and I have an IP address, so you just use the SMTP protocol. Now, as I said, it is mostly push. That means mostly the client will send the message to the server and say, look, I want to send this message. Until then, it will be, if the server is not available, your message might be queued in your own computer. So there is a queue in your computer too, right? Outlook has a queue, right? When the server is available, then it is pushed to the server. At that time, you have whatever IP address you have, that's it. Basically, that address is used. So I don't know if it's stable or unstable makes any difference.
I mean, I guess maybe it's a marketing term, but like BlackBerry's consider themselves having push email, meaning the server pushes the email as soon as it gets to the server to your BlackBerry device, for instance. And I guess that's what I was considering push, is the push email to the mobile device itself, not to the server.
So generally, now Exchange might be different because I haven't used Exchange, but generally, the mail is kept at the server until the client says that I want it. So for example, I don't have BlackBerry, but I have iPhone right here. If the email is there, but it doesn't come to me, I mean, until I go to the email program. When I go to the email program, it starts pulling everything from the server and says you have 5 emails. Right? If I don't go to that program, I could program it. Actually, it's just the program itself which decides not to do that. But I could have another program that could just pull it every minute and tell me that now you have 15 messages. But so that's all detail of the program, nothing to do with the protocol. The key part of the protocol is these messages that we talked about, and those are fixed. How the interface does it is there's a lot of leeway there. There's a lot of ways different interfaces provide different facilities to the user. All right. So the key point I wanted to say was that SMTP and POP are two different messages, the different protocol. SMTP is send, POP is for receive. Another receive is IMAP. Another receive is HTTP. Lot of people today are receiving email by web page. So when you have a web email, such as Yahoo, Google, everything else, you may not be using the SMTP and POP protocols. Those could be simple get and put messages, HTTP messages. So now POP3, in POP3, here's a sample POP3 sequence. POP3 server ready, you say user Bob, server says OK plus OK. Pass hungry, this is the password. And then it says OK, user logged in. Then it says list, client says list. Then it says, well, you have 2 messages waiting. First one is 498 bytes, second one has 912 bytes, and then they dot. Right, that means at the end of the list. Then it says retrieve 1. And so it sends you 1 and then sends a dot. Then you say delete 1. You don't have to say delete 1, but if you want to delete it, you say delete 1. Then you say retrieve 2 and delete 2, quit, and now. Next time when you come back, 1 and 2 are not there because they have been deleted. If you don't delete 1 and 2, when you come back, it will say I have 2 messages for you, again same messages. Yeah.
Does it not have a response for the delete command?
It doesn't show, so see like here, I mean it doesn't say okay deleted, I mean so I hope not, as shown here. Now this is something that I have not tried myself as opposed to the other telnet thing. This is from the book. Yeah.
If you delete 1, why doesn't it renumber 2 to B1?
Yeah, but I think it will renumber it if you just get out of there right now.
Okay.
If you quit and then you come back, it will say I have message 1 and that is 912 bytes. But right now, just for the sake of simplicity, because there will be 2,000 messages, if you read 500 message and then now you have to renumber the rest of them. So for this session, I think the numbers are fixed. All right, IMAP is Internet Mail Access Protocol. It is more sophisticated than POP3. Allows users to maintain folders. I have not used my IMAP myself, so I'm just kind of whatever is in the book. And messages can be moved from one folder to another, and the users can only get the header for the component of the messages, and there is the IMAP organization. So I don't, yeah, go ahead.
According to the internet, IMAP you can get push to your client saying that something's available, and then,
Yeah.
so there's a part leak push in there. So have
So the thing is, yeah, I mean, again, because we are not going into detail of IMAP protocol, in the POP3, there was no push as such. Basically, you have to say retrieve 1 to get the message, list to get the list. So you have to ask for it and you get it. Maybe in IMAP there is a command which says, oh, here is your list, even if you didn't ask. But I would be surprised though, because most clients like this, they are not ready for just a whole bunch of information unless they ask for it. So generally the servers don't take the lead. But
That's what cell phones can do. Cell phones can
no, they don't.
push email.
No. See, what they are doing is actually just the opposite. You have to differentiate between what is happening in the background and what you see in front of you. So it might say push email means it gives me a message saying that, okay, you got 46 email, but that doesn't mean that the server pushed it into it. It is pushing to you. Server would have gone to server and say, please tell me how many emails you have. So it is pulling from the server and then pushing to you. Pushing to you is not the same as pushing from the server.
That would take up way too much phosphor time. I feel bad. Cell phones aren't using that.
No. So this is why. This is why exactly the cell phones don't, actually my cell phone doesn't even right now pull the messages until I go to the mail program. So right now if I go and say mail, then only it will start pulling. Otherwise for 7 days it hasn't done a thing.
Sure, and you can configure it differently.
Huh?
And you can configure cell phones differently.
Yeah, I can configure differently. Then there will be, so for example in my laptop I have configured that every 1 hour it should go and pull. Right? I can program that it should go every 5 minutes and pull. Or it should program every 1 day and pull. So say your configuration thing, but not the protocol thing. You have to distinguish between the protocol and your configuration. How often do you pull? That looks like a push, but it's not a push, it's a pull.
It has to be a push, otherwise
Huh?
you're getting way too much internet traffic.
So basically, yeah, so you can program your mail program to pull every second. And you pay the cost of it because AT&T will charge you for that many bytes, right?
We'll continue this later.
Yeah. I mean, so I'm just saying, so this is not a part of the protocol or anything else. This is not fixed. This is user-based.
Yeah, it has to be.
User conversion. Huh?
It has to be part of the protocol because otherwise there'd be way too much traffic, and by default phones do.
So by default, okay, so the default is no pull.
Yes, it is. On modern smartphones, the default is to automatically get email.
Again, that is not the protocol part. That is the cell phone. You are not able to distinguish the protocol from the implementation. You are not able to distinguish Outlook from the POP3 and SMTP. I'm sorry, but anyway, let's move on. Because there is a protocol and then there is a users of it. So say for example, browser, Firefox does many things which HTTP protocol has nothing to do with. You can type in the Firefox Raj Jain, which is not a URL. It will just go to Google, find out the URL, and then open that page. But that is not part of the protocol HTTP. That is just the Firefox does it. Right? So they made that facility extra facility. All right, let's move on. All right, so I'm not going to go into detail of IMAP because really all I wanted to do was to give you an idea of the differences of these different applications, how they worked, and as compared to HTTP and so on and so forth. So we have done that. And so we finished FTP and Mail. FTP is a client server protocol and it uses the port 21. It uses 2 parallel connection. So again, when you use 2 parallel connections, that means you use 2 different port numbers. Port number 21 is for the control connection. And SMTP is the protocol to send email, and it only does 7-bit ASCII. So there is a whole detail how do you convert messages to 7-bit. And then there are other protocols that can be used to receive the email. Yeah.
What port number does the data go on?
What?
On FTP.
What port number? Yeah, that can be negotiated. So basically, what happens is there are 2 sites, 2 port numbers. So when I am talking, let's go back to a simple case, HTTP. HTTP, the server has a port number 80. But when the messages come back to my computer, they also need a port number to get in. Right? That port number is totally arbitrary. I could send to the server, say that please, I want this page and my port number is 3021. Right? When the server responds, because server is getting unannounced call, right? So it has to go to port number 80 if it, so, right? Because we have to know who to give it, right? But I'm not getting an unannounced call. When the answer comes back, it goes to port number 3021 because I said so. So this one side of the port is random, right? Similarly, in the FTP case, when you want to just tell the FTP server that I want to talk to you, you talk to port 21, right? And then you say, well, my control port number is 3023, and then connection is set up. We say user, password, and so on and so forth. Then I say, okay, I want. Then it might say, okay, for my data, please use this port number or whatever it is. So the rest of the things are all arbitrary. You need just the first time when you go unannounced, you need a standard port number. Yeah.
Is the port message provided by the sockets?
Okay, the question is who provides the port mechanism. So basically, if you go back to the, I am looking for a 7-layer model somewhere. I don't know whether it is in this slide set. Yeah, here it is. You see, at any point, we need an address to go to the next layer. So when we come from the Ethernet and there are dozen computers on this Ethernet, it has to know which computer to give this message to. So there is a Ethernet address that gives it to one of the computers in the IP layer, right? And actually there is a corresponding IP address. Then the IP, whatever gets it, so my computer got this message, now it has to decide which of these applications to give. So TCP, when it gives it to any, then it uses the port number. So port number is simply a TCP address. So TCP has one address for HTTP, one address for FTP, one address for SMTP and P2P and so on and so forth. So port number is nothing to do with the socket whatsoever. Port number is the TCP layer address. As the IP layer address is that 4-digit number, there is the Ethernet level address which we haven't talked about. So each layer has its own address. And actually applications have their own address too. For example, when you go to HTTP server, you give it a URL. URL is the address.
So
yeah.
If you want to make your own application, you just choose a port arbitrarily. There's somewhere you go to like a standardized.
Good question. The question is, suppose I have a new application, how do I get the port number? You have to go to IETF and you have to say, I want a standardized port number for my application. You have to make your case, and if they think that your case is important, strong enough, then they will give you a assigned number, and there is an RFC which has all these assigned numbers. Hold on. So once you get that, then everybody in the world will follow that. If you are not in that list, you are not a standard. So yes, there is a person who does assign. Actually, it used to be a person who used to do this in the old days. Now it's a committee. Yeah.
So this is a convention, right? Like all the ports are, you're not required to use one port?
Yes, all these standard ports you are not required to use. For example, port 80 you don't have to use. You can use port 81.
Your firewall might block your ports.
Yeah.
Well, I'm still on this post. We go to slide 8.
Slide 8.
So how does this socket get?
Okay, socket concept is basically an operating system concept. Nothing to do with the networking. In the original Unix, when process A wants to talk to process B, they opened a socket, which is now looks like similar to port number. But even if you are not going over the network, suppose you want to talk to another process on the same system, you will open a socket. Okay? Now, in the case of networks, what happens is each of the applications is talking to the TCP process, TCP IP process. It's a separate process. So they have a socket opened. And when port 80 comes in, it knows that port 80 has to go to that process. Okay, so socket is an operating system concept, port is a networking concept, and port is related to TCP and UDP. Okay, if you had another transport protocol which we don't have today, then they would have a different address mechanism, different address sizes, different whatever, but TCP and UDP use 16-bit port numbers. So the port numbers are between 0 and 2 raised to 15, 2 raised to 16 minus 1. Okay? All right. So this is homework number 2B. Again, you are supposed to read this and answer, and you can program your client any way you want. So for example, we are talking about you can program your client to read the email every 3 seconds, every 3 minutes, or never, and to delete the messages, or to not delete the message. Again, these are options in Outlook. In my case, I use the Outlook client. In Outlook, I can say, for example, when I read it on my smartphone, I say don't delete. When I read it on my computer, I say delete. And so you can do whatever you want in every client. So the download and keep mode complete the transaction. Suppose you configure to operate in the download and keep mode, then you have to answer what to do. So you have to read this about this more detail in your book, and then it will tell you exactly what will happen if you delete or don't delete the messages. All right. The next application layer protocol that we'll talk about is DNS. DNS stands for Domain Name Service, and we will talk about hierarchy, how it works, what are the different records, what are the messages, how do you register, and what are the attacks. So DNS stands for Domain Name Service. Now this is really not an application that you ever touch, but you touch it every single time when you do any other application, because in most applications you supply the name and it has to be translated to the address, and this is done by DNS server. So a DNS server has a record of every single host in the universe, not the world, universe. All right. If there is a name, there is an IP address, your DNS server should know it. Yeah.
So they literally keep a table that just.
Yes.
Okay.
So they're literally a big database. However, this is a distributed database. So if everybody had to keep, the whole universe's database, that will be too big. So I will show you how it is distributed. So it is distributed database of all hosts in the universe. And then it also provides name to address, but also provides other services. For example, you could say, what is the alternative name for www.rajjain.com? So this is a valid URL. However, it translates to this URL. Right? So all of you, for example, have a website in Washu. You could get a domain name like this yourself, and people could open the web page by writing the domain name, and they would not know that it is going to Washu. All right. You could have an email address which is your own domain name. So a lot of people, when you go to IETF, and everybody is a networking guru there, they all have their own domain names, and they all have their own email addresses which are very simple, bob@roman.com, whatever their name is. Yeah. That is valid. What name record?
CNAME?
E-name?
CNAME is like when you have one domain for another domain?
So this is basically host aliasing. What else is called? Domain aliasing. That's the only name I know. Now I don't know about e-name, so could be. Anyway, MX record is for mail server. So you could, for example, go to DNS server and say, where is the mail for, actually all it is I think doing is probably not looking at the whole thing. Where is the email server for boostal.edu? So if it goes to DNS and DNS says, well, mail for wustel.edu is received at mail.wustel.edu, and then it finds the address and then gives it to you. So the servers can then basically send the mail there. And load distribution, multiple addresses. So some sites have so much load that they cannot have one address. For example, google.com. Google.com gets so much load that if they just send everything to one computer, that computer will be overloaded, right? I mean, obviously, so not only if you do it in different cities, the Google address is different, but if you do different times, even right here on your computer, just do ping google.com, and then a few minutes later do ping google.com. Actually, you don't do ping, you say ns lookup, name server lookup. Here it is, name server lookup. If you do name server lookup, wustel.edu, you get the address. All right, you do google.com, you get a bunch of addresses. All right, so our DNS server knows 1, 2, 3, 4, 5 Google addresses, and when you ask for it, it will give you this list, but the list is rotated every time. So you ask it second time, it will give you this as the first address. Third time you ask, it will give you the same addresses, but this will be the first address, because most people just take the first address and use it. So by rotating, they want to make sure that the load is balanced. Yeah.
Is there any sort of protocol in charge of registering or tying a domain name to the server?
Oh yeah. Basically, when you get the domain name, your domain name registrar, and it might be a good idea for you to get a domain name because you never know when you will need it. So I have gotten it from my son and my wife and my kids and everybody else, and so if they need it, they have it. It costs them money. It costs $10 a year, but basically, so the idea is when you get then they provide all this. They provide the MX server, they provide the name server, they name to address translation, everything else is done by them as a service. All right, so how is this database distributed? Well, database is distributed by the names that you already know. So the root database is called .dot, and .dot has several children, .com, .org, .edu, .us, and all that. So hundreds of what we call subdomains. Then .com has many of them. So yahoo.com, amazon.com, and so on and so forth. Edu has umass.edu, wustel.edu, poly.edu, and so on and so forth, and org, and so on and so forth. And then washu has many children. So it will be cs.wustel.edu, and so on and so forth, law.wustel.edu. So, and then law has many children, and so this is the whole thing is a tree, and the tree can grow independently of the other parts of the tree. So for example, Wustel doesn't have to go and ask UMass, can I have a child named law? You can have whatever name you want for your child. All right, and so this tree, everybody is responsible for their part of the tree. So .com server is responsible for all the children. If Amazon.com changes name, changes ownership, changes something, then .com server has to know, right? So that it can correctly send the queries. And so this is called the root, is the top level, and these are the top level domains. And this list has been growing like anything. So every country has a 2-letter code. We have US, which we never use, but there are countries like TV and some other countries which are very much in demand, and CA is for Canada and UK and so on and so forth, right? So that is top level domains. And then when you want to get to any server, you can get to the authoritative DNS server. So if you want to know about any names in wustel.edu, you have to go to wustel.edu. So if you are here somewhere working for Amazon and you want to know what is the address for mail.cs.wustel.edu, Amazon would cache some of these answers if it needs it, right? But if just nobody needs it, then it will go to the root, come down to the wustel.edu and say, please tell me what is the address for mail.cs.wustel.edu, and then get it back to you. So that is called authoritative. Every organization is responsible for its own addresses to tell to the world. Okay? All right? And so you can go. There was a question here. Go ahead. What was your question? Done? Okay. Yeah.
So if, for instance, Wustel.edu is in charge of their own subdomains, why do they have to pay for a separate SSL certificate for every subdomain?
No. Hold on. Certificate is different. You are bringing up it totally different. For names, you pay only once, and you only pay for the top level. For example, I paid $10 or whatever for rajjain.com. Now I could create, Amit Jain, Raj Jain, Nilu Jain, whatever, subdomains. I don't have to pay anything. Names are free after that. Okay. Certificates is the whole thing. I haven't talked about certificates at all. And I don't know what certificates are until I talk about them, which will come in chapter 7 or 8. I had any other question? Yeah, go ahead.
So what is non-authoritative?
Non-authoritative. Non-authoritative is if I just have a previous answer. So suppose you asked me what is mail.cs.wustel.edu, and so I told you, but I also kept it in my cache. And then you asked me, somebody else asked me, so I can say, well, I think this is the answer. It's a guess, because it could have changed in the last few minutes. Right? So non-authoritative means, it's a best guess. And what will happen, actually this is all coming up in the next slide. The best guess is good enough because this saves you time, you got the answer right away, but you send a message there and it comes back, says not deliverable, then you will say to the server, look, I want an authoritative answer. All right? Then the server will make sure that it goes. It's like proxy server. Remember proxy servers? You can say reload the page, means I really want the origin server, you to go to origin server. Same way here, DNS. Now how does the DNS works? Okay. So first of all, every host has a host file. Right? So your computer has a list of names and addresses in that file. If that name is there in that list, it doesn't go anywhere. It just, I don't think this is working today though. It's not working. My throat is already hurting. Okay, I will work on this later. Okay. So if it doesn't find in that host file, then it goes to the DNS server, which you have programmed in your computer. Remember, when you set up TCP/IP, it says DNS server obtain automatically, or put the name, put the number. So it goes to the DNS server and says, please give me the answer. Now it may have its own cache, and it can give you the answer. If it not, then it goes to some other people. And when it gets the answer, it sends it back to you. Yeah.
So I heard that they're expanding TLDs for internet. So would that mean you need a lot more DNS servers then?
No, actually, so each TLD does not have to be a separate DNS server. Sorry, let me go back to the previous slide. This one. So for example, there is no need that yahoo.com and amazon.com be two DNS servers. There could be one DNS server. All right. So for example, com and arg, they don't have to be different. So by expanding this doesn't mean that you need DNS server, but obviously the number of names is increasing, and you need bigger and bigger DNS servers. All right. And and it actually is a good business for these people who are in this business, because they can sell a lot more names. All right, so there are two kinds of queries. One is called recursive query, give me an answer. Or iterative query is give me an answer or a hint. Come on. Give me an answer or a hint. So in this case, what this means is that if you don't know the answer, please tell me where should I go. So this is the question, like, I want to go to Kansas City, and somebody says, I go to somebody and say, well, can you tell me direction to Kansas City? And they say, well, I really don't know, but can you give me a hint? They'll say, maybe you should take 170 from here. That's good enough. And so that's the kind of answer you can get, is that you could go to the DNS server, and actually more likely your DNS server will go to some other server and say, where should I go? And they will say, well, go to this top level domain server, and they might say, well, go to the UMass server, and then from UMass server you will get the answer. So that is an iterative query. Recursive query is give me an answer. What that means is that if you don't know, then please go and find out and then come back to me and tell me. So this query, for example, is a recursive query here. From the user, this is a recursive query because I don't want to go to top level domain, I don't want to go to UMass and all that. Please go and tell me, find out. So this one will do iterative query from here, but the computer is going to do a recursive query. Yeah, go ahead, question.
So from here it looks like everyone needs to install their own DNS server.
Everyone?
Yeah, for the authoritative answer.
Yeah, no. For the thing is, authoritative answer, for example, this doesn't have to be, for example, umass.edu server could have all UMass names, including DNS.cs. everything else. So this is one server which is authoritative for whole UMass. Okay? It might have many domains there, subdomains and subdomains and subdomains, but each of them don't have to have their own server. For example, in our whole department, I think there's just one server. CSE has one server, even though there is CSE and CSE can have its own names, and so there is no separate server for those names, and there is no separate server for CSE. All right, is that clear? How the domains work and how the service works? All right. So the DNS records have very simple database. Basically, they have a name, value, type, and time to live, TTL. Type could be A, means address, NS means name server for the domain name, C name is the canonical name. Somebody said E name, you were using the word E name, but it is C name is the canonical name for the host name, so it is alternative name. MX is the mail server. So the type indicates what kind of record this is, and there is A record, NS record, C name record, and MX record. A record is simple IP to address translation. MX record contains the mail server addresses for that name. C name contains the alternative name for that name. NS is the name server for that name. So there are many records, and each of them have a TTL. TTL is time to live. So if you go to UMass, or if you go to, let's say, Facebook, well, not really Facebook. Well, so whatever you go to, and then you get the answer, that answer is good only for so many seconds, or so many minutes, or so many hours, or so many days. Things which change fast. So for example, if you have a smartphone, IP address would be changing very fast in the day, right? So that answer that will come back from AT&T or Verizon would have very small TTL. Whereas if you go to Boostel, unless you are connected by wireless, it might give you a long TTL. It will say this address and this is good for 24 hours. Right? So depending upon the mobility, the address changes and the TTL changes. Okay? Alright, so we have name, value, type. So we talk about type and name and value. Basically, name is the ASCII character string and value is the binary string. Messages are basically like this. You have identification field, some flags, then how many questions you are asking, how many answers are there, how many authoritative answers and additional answers. So these things, and then you have questions, all the questions, all the answers, all the authorities, and then additional information. So what is a question? Question could be simply that here is the name and I want the MX record. So name and the type. Answer could be name, type, value and TTL. So the answer should be there. Authority is the server that gave the answer. And additional information is, if it is you ask a question and then we give you more information, for example, you just ask for the canonical name, then we might give you IP address as well along with the name. But the canonical name is just the alternative name. Alright. Now how do you get a registration? So you can, there are many registrars. There is a big competition among the registrars. So you can go to any of these registrar and say I want this name. They will say this name is available or not. Once it is available, you just pay them $10 and the name is yours for 1 year. And then you pay $10 every year. And actually the way they do business is that first year is $10, next year is $20, because once you become a customer, they got you. So you have to change the registrar every year to find $10 deal. But you can get that. So there is a competition among them. And previously it used to be free. In the beginning there was a guy who just went and said I want this name, and they will write it down, the name and just like the port number, they would write down the name and the address and done. But that person has died now, and now it's a whole committee. It's not even a committee, now it's the whole world. I mean the whole set of businesses. So there is ICANN, Internet Corporation for Assigned Names and Numbers, that ICANN basically accredits registrar, so it has to be accredited by them. And then there is a company called Internic. Internic is the central thing. So all these registrars register with Internic. So you buy the name from GoDaddy.com. GoDaddy.com goes to Internic.com, Internic.net, and registers there. Once it is registered with Internic.net, then everybody knows that. Registrars provide authoritative name servers, A and MX records for the domain. So when you go to the registrar and pay $10 for that, they will provide the name service for you. So if somebody goes and says what is the address for rajjain.com, my registrar will provide that. That is the official authenticated answer. So if Vashu, for example, goes and says, okay, what is rajjain.com's address, it will go to my registrar. They have a name server that has the official answer. Yeah.
What if you just go to the name and you don't have a website?
Yeah, so the thing is, the minute you buy the name, you have the address specified. Actually, here thing though, I mean, like basically, few things here. If you bought the name and you don't have the website, then their record will probably be blank or 0 or whatever it is, right? But you have the option of providing some other website to be used. And so, for example, I put my Vashu website, and so they put that address, Vashu address, in that record. But they also sell you then. Here is the thing though, I mean, like they will sell you any service you want. They will sell you a single page, free page, or for $1 or $5 or $3, some deal, to put a page which says, this is your page, under construction. Yeah.
So you're paying them to run a server to keep all your web pages and for me.
For everything they charge you money. So they can provide you email, they can provide you name service, they can provide you web service, they can provide you FTP service, and for everything there is a charge. Right? So I use the minimum. I'm just telling you my own experience. I use the minimum. That means I just pay them for the registration, which is $10 a year, and everything else I do at Vashu. Right? Vashu does the email, Vashu does the web page, and everything else. All right. So it might be a good idea for you to get your own name, because once you become a networking expert by taking 473, you can go to somebody and say, look, I'm a networking expert. My email is whatever your name is, and say, well, my email is, bob@myname.com. Impressive, right? And then you can explain all about DNS and MX and everything else that you know. All right. Attacks. So DNS is also a source of attack. So first of all, if nothing else, people have tried this and they have succeeded in attacking the dot server, the top level server. So at one time, few years ago, some people attacked the dot server so that nobody could get any name resolved. There was so much traffic that you could not get the name resolved. That means you could not go anywhere. All right, now that has been solved by having 12 dot servers. Right? So there is not a single dot server but n dot servers. So that is resolved. But then you can also do cache poisoning. You could install a server that gives all the wrong answers. So it says, well, I know that rajjain.com is this, and here is the address. YouTube.com exists in Pakistan, and that happened. Okay? All the traffic went to Pakistan. All right, and it didn't get anywhere. All the YouTube traffic went to Pakistan. Right? So you can do that too. Right? So now that has been resolved in the sense that now the servers don't talk to each other and just take your answer. They have to authenticate that you are really the server that you are saying you are server. So there is a password and authentication and certificates, all those things. But initially there was no such thing. Okay? All right, so that brings us to the end of DNS. And so DNS now you know is, what are the 5 key things? First is DNS is used to resolve names to IP addresses, but it also now started providing other services such as names to alias names, CNAMEs, mail server records, and so on and so forth. It's a worldwide or universe-wide distributed database, and therefore the servers go and ask other servers for answers when needed. And you can have either a iterative query or recursive query. Recursive query means answer only. Iterative query means basically give me a hint and then I will go and find out the answer. Then there is root servers, and there are top level domain servers and authoritative server for every name. There is authoritative server. Okay. Any question about DNS? All right, then we move on to P2P. So we will talk about why P2P is better than the old method. Then we talk a little bit about BitTorrent and distributed hash tables and go down from there. So P2P. P2P, the way it works, and how many of you have not done P2P? Anybody clean here? No. Everybody has done P2P. Well, actually it's not bad. It's not all bad. But P2P, if you have not done it, you are not living in this world right now. So if you are alive and well, and if you need any information, you got to get it by P2P. And P2P is actually better than the old method, as I will show you in a minute. Basically, what happens is when you want a file, for whatever reason, currently it works, the way BitTorrent works is that you go to a website and they tell you that here is the torrent. Torrent is nothing but a file which has all the information about that file. So it is not the file that you want. You want a movie which is 722 megabyte long, and that file is only 40 bytes or 100 bytes long. Torrent. Once you get the torrent has much information about that file, and one key piece of information is where the tracker is. So one piece of information in that torrent file, if you can read it, says that all information about this particular copy of the movie is at this particular website. not a website, torrents, I mean whatever, torrent server type. So you go to the tracker, and the tracker has a list of all the people who are exchanging the file right this second. All right, so you get the list of all the people who are tracking this file, who are exchanging the file right this second. Then you contact them and connect them and say, can I also have a piece of this file? Right? So torrent. So now this is a name actually. So although that file which has an extension torrent, we call it torrent file, but torrent is the whole set of peers that are exchanging that file. Right? Some of them are called seeds and some of them are called leechers. Who are the seeds? Everybody should know. The ones that have complete files. Right? And leechers are the ones that have incomplete files. And so there is some kind of, just you give me one, I will give you one kind of deal, which I will talk about in a minute. So that's how you exchange information, and finally the leechers will become the seeds, and there will be more seeds or less seeds depending upon when the seeds leave, and all this is being monitored by the tracker. Tracker keeps track of all the people who are coming in and going out of that place, of that group. Now for every file there is a separate set of torrents, separate set of seeds, for separate sets of tracker and everything else. Okay, so you have to do that. Now, so let's see how it saves the network bandwidth. So P2P saves the network bandwidth. So if you have one server which has the original file and you have n people who want it, in the old method everybody has to go to the server and get the file. Excuse me, is there something interesting going on there? Or?
No, we're trying something else from that. We're just trying something else.
Okay, all right. Because you want to share something which is interesting here. So here's the thing. So if you go to the server, how many bits you will have to send? How long will it take? Each of these users has a downlink speed of dn, and actually this is just the opposite. It has a downlink speed of un, uplink speed of dn. Doesn't make sense. Uplink speed is ui and downlink speed is di. I think I would change the arrow directions here so that uplink becomes like that, downlink becomes like that. This is correct. D1 is correct. D1 U1, D2 U2 is correct, and US is correct, but this one is wrong. N is wrong. So anyway, so these are the speeds. Everybody has a different speed. But anyway, if you take the dmin of all the downlinks, that will take the longest to get the file, and it will, if the file size is f, speed is dmin, this is how long it will take to get that file. And since n times f bit have to be transmitted, what is n? N is the number of users and f is the file size, so n times f bits have to be sent by the server, and the server's speed is only us. So you divide by that, so maximum of that much time will be taken if you want to do client server. That is how long it will take for the file to go to all the people. On the other hand, if you do P2P, then only one client has to get it. So only one file has to be sent, and that can be sent at the speed of f upon us. And if that happens to be the bottleneck, then that will take f upon dmin to receive. And then, although NF bits are being exchanged, but everything is being done in parallel, and therefore all these uplink speeds will add up, and that is how long it will take to upload the files. Right. So the minimum of those three numbers in the bottom will give you how long it will take to get the file by P2P, and the second number will show you how long by client server, and you can plot these two numbers for any particular case. And so P2P is here in the bottom blue curve, and client server is here. So unless you had one client, P2P always wins. Okay. So basically the idea is distributing the load. Okay, excuse me. Anything do you want to share with the class? Okay, then please pay attention here. So the idea is client server, the old method is, at least in terms of delay, is not very good. Right? And although in terms of traffic, let's see what happens in terms of traffic. Let's just see the previous slide. How many bits were transmitted in client server? How many bits were transmitted? Anybody? The file size is F, n times F. And how many bits were transmitted in the P2P? Same NF. So the total traffic number of bits is same, but this one is all coming from one location. So there is a lot of congestion, whereas this is distributed traffic. P2P is distributed traffic, but client server is all coming from the server, and therefore that causes a bottleneck. So in terms of bottleneck capacity, again P2P wins. So alright, so I think we already talked about how BitTorrent works. The way BitTorrent works is that the peers are the node that participate in a file distribution. Torrent is the set of all peers. Torrent file is the file which contains the name of the tracker and all the file details and everything else. Files are segmented into equal chunks. So that's the new word, chunk. So the files could be different sizes, but whenever we want to get something, we get in 256 kilobyte unit. Everything is sent in 256 kilobyte unit, and that is called a chunk. All right, we already know seeds, leechers, and trackers. So basically, the steps are that if you want to get something, you first find the torrent for it. You go to Google or you go to some other place and you find the torrent for whatever information you are looking for, and then that torrent has the name of the tracker. So once you upload into your BitTorrent client, it goes to the tracker and gets a list of peers. Now tracker may have 2,000 peers, but it will not give you the whole list. It will give you some top 50 maybe. Then you set up the TCP connection with those peers in parallel, and each peer will tell you what chunks they have. So somebody has chunk 1, 3, and 5. Some people have 5, 7, and 8. So you get the whole map. And then you request the least available chunk first. So that's the rule, is that if you, because it's quite possible that the guy who had just chunk number 1 can leave any second. So get that chunk number 1 first, and before he or she leaves. So get the rarest first. Every 10 seconds you recalculate the receiving rates. Every 10 seconds you calculate the receiving rates. So you calculate what rate I am getting from this user, from that user, from that user, and from that user. And unchoke the top 4 senders. The top 4 people who are sending to me, I will send it to them too. Alright, even though it is the same file, you don't have it, I don't have it, but I am collecting pieces of it, you are collecting pieces of it, and I will help you get faster because you are helping me get faster. Alright, so I will unchoke the top 4 senders. every 30 seconds I will randomly select a peer and unchoke it. So while the top 4 are by mutual this one, but I will take one random one and add it to the group because I want to see whether they will respond in kind. If they respond in kind, then they get in the top 4. So this way it helps find the high rate neighbors. So this way we find out who are the neighbors who have high speed links and who can give us faster. Yeah.
So you're dropping one of the other 4?
Yeah, you're dropping other people. So basically, if there are, let's say I got this list of all 63 senders or peers, I will try connections with them and I will see how much is coming in, but those guys are too far away. I'm not getting, but I'm getting too much from these 4 people. I will concentrate on these 4.
And every 30 seconds you'll still randomly drop one.
Yeah, randomly select one more. Yeah, every 30 seconds you do randomly one more. Huh?
So there's 4 that are top and then there's one random one you're connected all the time. You drop that one.
And you could have more than 5 too. Basically what will happen is you take the top 4 then. So basically the people who are, so I mean I could be, so if you go to BitTorrent it tells you how many it is connected to seeds, and so there is a number, it says okay I have a total 50 and I'm connected to 10. Those numbers are visible, I mean you can see it in your client. And so it is connected to a lot more clients, but then it takes the top 4 and then basically it unchokes them in the sense that it sends them more information basically than the other people, right? So the more upload, so here the interesting thing is that if your upload speed is very low, then your download speed automatically becomes low. Alright, if you increase upload, then your download increases, but I have found that basically what happens is your computer becomes so busy uploading that it doesn't have capacity to download. So you get bottlenecked that way. So you cannot have upload too much either. Alright, so there is some optimum for the upload and download relationship. Alright, so that's the thing. Okay, you can read more about it in Wikipedia. I think that would be a good place to stop. We'll come back to this slide next time.